Alrighty, so topic 4 in your notes is about evaluating functions. We've been throwing around the word function, but we haven't really talked about it. So here's a definition. A mathematical function, as the word goes here, pretend that's in the right spot, expresses a dependent relationship where one quantity depends in a systematic way on another quantity. I'm going to say that again. It just shows a dependent relationship where one thing depends on another. So a function, just like an equation, takes an input and gives you exactly one output. That's important, exactly one. We're going to go into more detail on functions on Monday, actually, but for now, that's all you need to know. A function shows dependency. One thing depends on the other. So here's an example. Brittany has $4 in her piggy bank at the beginning of the school year, or the beginning of the year. She plans to save $3 every week for the remainder of the year. This is an example of a function because Brittany's money, the amount she has in her account, depends on the number of weeks, right? So if she's been saving money for 20 weeks, she's got more money than if she had only been saving for 2 weeks. So it says write an equation. Well, her money, we'll call it y equals, she currently has $4, but we're going to add to that $3 every week. So y equals 4 plus 3x. So then it asks you, after 12 weeks, how much money has Brittany saved? Well, you're going to end up doing y equals 4 plus 3 times 12 weeks. So then we PEMDAS, 4 plus 36, all that is 40. So $40. But let's recap what we just did. Our input here was 12, and our output ended up being 40 because we plugged in the 12 and out came the 40. Okay? That's all on the slide. So the equation you wrote above can also be written using function notation. That's really the focus of today. It's a way of writing equations where f of x replaces y. It says it is read as f of x. So the parentheses, it's f of that x. In function notation, your input is still x, that hasn't changed, but your output is now the f of x. Okay? So it's pretty much like your y. F of x is really the same as y. So to find f of x, simply plug in the value of x, found inside the parentheses, into the equation everywhere you see an x. Okay, so I'm going to show you how this looks with both types of equations. So on the left-hand side in this box, we have just normal y equals 3x plus 4, same equation from before. It says, what is y if x is 2? Well, y equals 3 times 2 plus 4. So y equals, we do this in our head, 3 times 2 is 6, plus 4 is 10. Okay? But now let's look at how it's written over here on the right-hand side. This is what we're moving towards. It says f of x equals 3x plus 4. So notice, f of x, that's the same as the y on the left-hand side. So don't let it trip you up. It says, what is f of 2? This question right here and this question over here are the exact same thing. Notice just the one on the right is shorter. When it says, what is f of 2, they're just saying, what is it if you work out with the 2? So f of 2 equals 3 times that 2 plus 4. Because notice, where there's normally an x right there, there's now a 2. Okay, so that means the x needs to be 2. So f of 2 equals 10. Okay, so let me kind of, again, switch gears here. Let me pick a different color. This thing I'm circling in green on the left is the exact same as this thing in green on the right. I always have a lot of people who are like, why are we doing this? Why does this matter? Okay, and let me kind of explain why by using this thing. If I get it to work. Maybe I just, did something. Oh, there we go. It would work. Okay, there we go. So if I cover up the whole top and I just have you look at these two green boxed in things, and I say, okay, for the left-hand side, we know that y is 10, right? That's written here. But what is x? You might remember that it's 2, but if this is all that I show you, we have no idea what x is. Whereas over here, we see, oh yeah, okay, y is 10, cool. And what was x? Well, I can tell because it's written right here that x is 2. So the reason we use function notation is because it gives us more information. It tells us what was plugged in as well as what is going to come out. Okay? So, is that everything on this one? Yep. Move right along. So it says evaluate the function evaluate the following using the function for Brittany's savings. So again, her function was f of x equals 3x plus 4, or 4 plus 3x, either way. So part A says, what is f of 6? That means that we're just going to plug in the 6 for x and work it out. 18 plus 4 is 22. The answer. Next one, again, oh, sorry, word's weird there. 3 times 10 plus 4. Well, that's 30 plus 4, so 34. Next one is 25. 3 times 25 plus 4. Well, that's 79. See what we're doing here? Very straightforward. You're just, whatever is inside the parentheses gets plugged in for x. So that would be 31. So then it asks, what do the number of parentheses represent? The x value. Okay. So it says, remember, just kind of a side note, domain is the same as x, is the same as input, and range is the same as y, which is also now, we're going to add this in here, same as f of x, which is the same as the outputs. Okay? So now it's just a bunch of practicing with function notation. So my next slide, they've given us some new equations to work with new numbers to plug in. So on number 3, it says, what is f of 3? Well, that just means I put the 3 where the x is. So what is 3 minus 9? Negative 6. Looking over here at number 4, same story. The x is negative 2, so I'm going to plug that in. This one's a little bit trickier just because there's a lot going on in the equation. So I'm going to put my negative 2's in parentheses just so I don't forget where I'm plugging it in and what I might need to work out. So I'm going to start with my exponents. Negative 2 squared is 4. This piece right here, negative 3 times negative 2, that's a positive 6. Now I just have addition all the way across. We get 12. Okay, number 5 says, what is the input? So they're actually asking you this time to find the x if the output is 7. So I'm actually going to put the 7 here and then solve backwards for x because they're asking you for the input. So I'm going to add the 1. So 8 is 2x. Divide by 2 on both sides. So x would be 4. The input here would be 4. Okay? So number 6, again, look how they're saying it. It says, what is x? So this time we don't know x when f of x equals 28.5. So 28.5 is what they're giving us, and we're trying to find the x. If at any point, remember when you're watching a video, you feel like I'm going too fast, you always have the ability to pause, right? It's kind of the beauty of a video. Rewind, listen to me say something again. You can watch it at your own speed. So on that one again, x is 4. Okay, 2 more on this slide. Evaluate f of x equals 4x minus 3 when the domain is negative 1, 0, and 2. Well, this is a little bit different because they're not presenting it the same way. But when they say when the domain is, that means that they're saying when the x's are negative 1, 0, and 2. So essentially what they're wanting us to do is take this little equation and plug in each of those for x. Okay, so I took that 4x minus 3 and I used these as my x's. Okay, so I'm actually going to have 3 answers here. So we'll work this one out. 4 times negative 1 is negative 4, so negative 7. Negative 3 and 5. Those would be my answers there. I actually have 3 answers because they gave me 3 x's to plug in. Okay, number 8, just fill out the table for the function t of x, which sometimes happens, I use a different letter, equals 4x minus 8. Well, again, all they're saying is, again, here are the x's. This is no different from what you've been doing for a few years now. You're just going to plug these x's in to your equation for x. So I'm going to calculate this first one by doing 4 times 0 minus 8. Next will be 4 times 2 minus 8. Okay, so I'm going to pause just to save time. Okay, so there's what I got. If you want to pause and take time to actually work them out yourself, go for it. I always suggest that. I just try to make these videos as short as possible because I'm kind of long-winded. We're already on 10 minutes here. Alrighty. Now, this is completely different as far as how it's presented, but it's the same thing as long as you remember x's and y's. It says use the graph. What is the value of f of 8? Well, all this is saying is that x is 8. Okay, so I'm going to look over here on my x-axis and find where x is 8. Well, the point, what's its matching number over here? It'd be 0. So my answer here is 0. This is what is the value of f of 16? Again, 16 is my x. I'm going to go down here to my x-axis. Here's 16. So I'm going to read it all the way up the graph. Here's the point. So 12. 12 would be my answer there. Okay? It's kind of the equivalent of saying what is y when x is 8? And what is y when x is 16? So now C and D are the opposite. It says for what value or values of x, so they're asking us for x, does f of x equal 4? Okay, so let me change colors here. This time, they're giving us y. Okay, it says f of x, remember that's the same as y. Make this a little skinnier. So I go to 4. Here's my 4 on the y-axis, and I go across. Well, it actually has 2 points on it, here and here, so 2 answers, 4 and 12. Okay, then for what values of x does f of x, so again the y-axis, equal 16? Well, that's right here. I'm going to read it across. I have 2 points again, here and here. So it'd be, what, 18 and 24. Okay. I'm going to erase my graph now that I have finished this problem just because it gets so busy. But it says now, for what values of x is f of x greater than or equal to 10? Well, again, they're saying f of x, so that's the y-axis here. They want to know when is it greater than or equal to 10. Well, here's the 10 line. So greater than or equal to would be above this line. Well, that starts here and then continues all the way. So for what values of x, that would be, let's see, 14, that'd be 15 for what values of x, so 15 and on, right? And I'm doing inequality for this actually. Anywhere from 15, right here, all the way across to this point, which would be 26. All those values of x's. So this x, this x, this x, this x, and this, and so all of those are going to hit a point on this continuous line that is greater than or equal to 10. Okay, last thing, what is the domain and range of that graph? Well, domain is from left to right, so it goes from 0 all the way to 26. Oops. And range is from bottom to top. It goes from 0 up to 20. Okay? Alrighty, so now we're going to use a table. We've done a graph, we've done equations, now let's do a table. So what is the value of g of 3? Well, again, they're telling you an x. Whenever they have the number of parentheses, they're telling you the x. They're saying x is 3. So over here, here's where x is 3. Oh, sorry, my circle's off. My answer was 6. It says, what is g of 5? Well, again, let's see if I can get it right this time. Here's the 5. My answer would be negative 3. Then it says, when g of x equals 6, well, that's this side of the graph. When g of x equals 6, what is the value of x? Well, that was the 3, right here. I can get it to circle. Okay, this is when g of x equals negative 3. What is the value of x? This one's a little bit different because I have 2 of those. I got one right there and one right there. So I have 2 answers, 5 and 8. Now, here's a tricky thing. There's actually a typo here. It says, given the table, if a new function, this is supposed to say, if a new function f is defined by f of x equals g of 3x plus 1, what is the value of f of 2? Because that's all messed up, we're not even going to do it. If you were really curious, because you just are a fun math nerd like me, I'll show you how to do it later, but it's not important for today. Okay? So, looking at number 11, evaluate the function f of x equals 5x minus 3 for 2 times f of 3. All that means is 2 times, let me put some brackets here, whatever f of 3 would be. Well, let's go do f of 3 first. That just means I need to plug in a 3 for my x. So 5 times 3 minus 3. 15 minus 3, so it'd be 12. Now I'm going to go put my 12 in there. 2 times 12 is 24. So anytime that you've got these brackets on the outside, it's saying, again, like PEMDAS, you're going to do your innermost parentheses. You do that f of 3 first. That's what this was over here, just normal f of 3. And then you just multiply it by the 2 because it's on the outside. Okay? Alrighty. A few more. So practicing what we just talked about. Number 12 says 3 times whatever f of 2 is. So let's work out f of 2 first. So it'd be 6 plus 2 would be 8. But then it's saying 3 times that. So 3 times the 8 would be 24. Other side, same thing. They need us to work out f of negative 1 first. So I got negative 3 plus 2, so that'd be negative 1. But I'm doing 4 times that. So negative 4. Okay. 14 is a little bit weird. Actually, it's a lot of bit weird. Let's hold off on that one too. I'll do that one as like a warm-up one day. So skip. Don't like completely annihilate that question. We'll come back to it another time. But here's some other ones that make more sense. Find the range for the equation 2y minus x equals negative 10 if the domain is negative 116. If they're saying find the range, they're saying find the y's. And if they're saying if the domain is, they're saying here are the x's. So I'm going to write this equation, but instead of writing x, I'm going to plug in those numbers. Okay, and I just happen to have 2, which means I'm going to have 2 answers. So 16 equals negative 10. I'll work these 2 out, and I'm going to have 2 answers for my range. So this is actually 2y plus 1. It's negative 10, so let's subtract my 1. So y equals negative 11 halves. That would be one of my answers. And then y equals 3 would be one of my other answers. So if they're saying find the range, my range would be negative 11 halves and 3. Okay, you'd have to use both equations there. Okay, now it says using the equation from situation card number 7, determine what f of 10 would be. Well, you don't have the cards in front of you, so let me just let you know. Situation card number 7 is, of course, I'm going to have to flip through because I was not prepared. Here we go. It was about a girl being a really fast typist. The equation was y equals 85x plus 250. So when it says what is f of 10, that means we're plugging in the 10 for x. So 850 plus 250 altogether will be 1100. Alrighty, I think that's it. Woohoo! So once you have finished writing down all these notes, and if you've finished going back, rewinding, looking over things you might have missed, you do have a practice page in Schoology. No, you don't. That's a lie. This is all a lie. You don't have a practice page in Schoology. We're going to do it on Monday in class. So you have no homework. If you've made it all the way through this really long 20-minute video, you've done all you need to do. Okay? You're good to go. But I would say fill out your TEKS checklist. We just did actually this box right here. Okay, so ignore that one. You've already done that one. So we have now evaluated functions and function notation. So you've had your first exposure to it. I would fill that out, and then you can really and truly call it a day on this 19-minute video. Let me know if you have any questions when I get back on Monday. See you then.